Okay, so I had already run this before. For some reason, I can't get the audio to work when I do a saved or recording off Zoom. So I'm gonna try this with my phone. As you can see, I started on my answer sheet. Um, I will come back to this throughout the video just to talk about um, each section when I hit them. So basically, this was the audit that we did. We got this information from the market data when I went to add both the year and the month. Um, so that's how I got this info, and so it'll show all the years from 90 to I believe 2018, if I'm not wrong. I can, nope, 2020. Um, So that's the audit that I had done with this information. And basically, how I got it was by doing the formula with the year and then getting the date that was already given to us in the Excel. And then the same thing here. I just did text and did the month, which we got again from the month or from the date. Um, we were also given this S&P 500 and the VIX. Everything else throughout the assignment I added. So basically columns F through K. Just want to make sure that it's still looking good. So then we went here and got the statistic profile. This was actually the first time that we did the data analysis in this class. So you're able to see the median, what was the mean, the median, the mode, and also the range and the sum. I think those are probably the most important for the S&P 500 and the VIX. And we were able to get this info again through the data analysis of this info. For the correlation data, we did run a pivot table to get, and we looked at the sum of S&P change and the sum of VIX change. As you can see, the grand totals were still both negative, but the VIX change was less of a negative. And you can see the output of both sums was still in the negative, which I actually got for question 43. I had said that when discussing the correlation output as it relates to the S&P 500 and the VIX, I learned that there is a negative correlation between the two because we got that big long decimal, which makes sense when you're looking at the numbers. We do get from the pivot chart on the left hand side of the correlation data. What I'm talking about is right here. You can see that it makes, again, with the grand totals. Then we went to the correlation analysis, and the line is actually going to be the VIX change. So you can see there was a huge dip in February, then a huge rise in April. And then for the bars, that's actually going to be the sum of the S&P change. So you can see that January, February, March, and September were positive, but there was a negative drop in April, May, June, July, and August. And then just want to check again. For the VIX analysis, basically what I did was, so this is the sum of the VIX days above 35. And what I mean by that is if you go back to the market data, this was definitely the most important that we did, just because this was like where we got the info to answer all these. But anyways, so to do the above 35, I had to add that column, and we put in a formula where if E2 was greater than 35, then, whoops, let me go here and then hit back. Okay, there we go. Basically, if it was greater, then we put a 1, and if it wasn't, then it was a 0, so that's why there's a 0. But as you can see, like scrolling down, a lot of these are going to be 0, which I hit on in one of my answers, which I will look at later. But as you can see, like for this one example is 1990 August. There was a 1 because it was above 35. It's actually 35.91, but it is kind of rare for it to have a 1. A majority of this you're gonna see zeros. And so basically this is just adding up. So in like 1990 there were only 2 that were above 35, but then you look at something a year like 2009 who actually had 82. That was actually the most that I found, and I believe there was like 7,000 something um pieces of information, like data, that we were given, and only 339 were above 35, just to show like how rare it was. And I guess actually I can go to the answer sheet now and talk about that. So basically, I was talking about how so there's 7,746 data points that we were given, and out of that, again, it was only 339 days that were above 35. So I kind of just did the quick math on that on my calculator, just to find out that that's 0.04 of the days. So again, super rare. And so then going to the next one, yeah, okay. So then basically we went and we wanted to take the trend of the sum of VIX, total days above 35, and then the sum after the trend. So I was able to get into, and also this was for 2011. We did do ones prior to that, and I believe 2008, 9, and 10. But then the last one was, we were looking at 2011. And as you can see, we got 6 of them, and then that the sum trend was negative 3.2. To look at that other one, I was having an issue when I would select on the percent of column total for this part of the assignment, because for some reason it would show me the total, but then when I clicked on that, it was always showing 100%. And obviously, it being so rare, I know it's not 100%. I know that, in 2008, 100% of the days were above the 35. So I don't know what was going on there. So I did leave that off just because I was having issues. Just to point that one out. Then for the final thing, we did do a regression, and we looked at these specific days that were given right here, column C. And then the change one day after the trend. And basically, we use this information to get the regression output. And in my last answer, when running the regression, we were told that we had to look at the multiple R, or multiple R and the adjusted R squared. To be honest, when I was in stats, I don't remember us going over that, so I don't know what these two numbers mean. But what I do remember is that the p-value, when it's above 0.05, then that means the hypothesis is false. So like the test that we were running, or it should be rejected. And when it's also greater than 0.5, that also means that there was no effect that was observed. So when looking at these, let me go back to it. When we were looking at these specific days from the analysis, there was no change in like observed, and that our hypothesis that we ran was false. So this is what I did for our final project, and yeah.